So now I'm going to show you a method called synthetic division. And this one will actually be quite a bit easier than the long division. It usually goes a little bit quicker. The only problem with synthetic division is that in synthetic division, your divisor has to be a linear polynomial, meaning first degree, and the leading coefficient in that divisor has to be 1 in order to perform synthetic division. And this is the way synthetic division works. Okay, so, and we work just with the coefficients. Now, and again, I have another stray mark. I need to get rid of. Now, in this box goes the constant of our divisor, except we're going to switch the sign. So it's going to be -5. Okay? And here we're going to put the coefficients in the dividend. So here goes 4, 23, and -16. Okay? And then we're going to put a little box here, because in that box is our remainder. Okay? So to start off this synthetic division, the first thing you do is just bring down the 4. Okay? And now what you do is you take this number in the box, multiply it by 4. So -5 times 4 is -20. And now all you do is just add these. 23 and -20 is 3. So then once again, you multiply the -5 times the 3, you get -15. And again, you add those to get -31. Now, here is your quotient. Okay? And right next to this line here, remember this is the remainder. Right next to this line is the constant term, then the linear term. And if we continued on, then it would be the quadratic term, the cubic term, the quartic term, and so on. But this one stops at the linear term. So, to write this in quotient remainder theorem form, we take the dividend, which is 4x squared plus 23x minus 16 is equal to our divisor, which is x minus 5, times our quotient, which is right there. And since it was a linear quotient, 4x minus 3, and then plus our remainder, -31. Now, if this problem looked familiar, good. We did do it yesterday using long division. And I think you'll find that the synthetic division goes much more quickly. Now for our second one, B, synthetic division, again, we're going to put that constant in that box, except we're going to change the sign. So if it's x minus 7, we put a +7 there. Do not forget to change that sign. And then straight out from the box is our coefficients from our dividend. So, always again, keep in mind that whatever ends up here is our remainder. So, in this case, first thing you do is carry down the 3. You're going to bring that straight down. And then you're going to take the number in this box times that to get 21, and then you just add these two. So then -29 plus 21 is -8. 7 times -8 is -56, and when we add these, we get 0. So our remainder is 0, so we have no remainder. And again, constant, linear, quadratic, cubic, quartic, and so on down the line. So this is just a linear quotient. So to write this in quotient remainder theorem form, 3x squared minus 29x plus 56 is equal to our divisor, which is x minus 7, Ooh, that was plus 5 back here. Better change that. X minus 7 times our quotient, 3x minus 8, plus our remainder, which there isn't one. So in the next one, this one poses again a fairly interesting problem. Again, positive 2 will go in this box, and then straight out from the box will be the, oops, sorry about that. Let me resize that, there we go. Will be the coefficients of the dividend, but if there are gaps, like the x to the 4th term, and the x to the 3rd term, and the x squared term, and the x term, make sure you fill in those gaps with zeros. This is vitally important with the synthetic division. So then, what we are going to do is first we bring down this 1. 2 times 1 is 2. Then we add these two to get 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. 0 plus 16 is 16. 2 times 16 is 32. Negative 32 plus 32 is in fact 0. So, linear term, constant, linear, quadratic, cubic, quartic. So our quotient is actually a quartic. So to write this in quotient remainder theorem form, we take our dividend, which is x to the 5th minus 32, is equal to our divisor, which is x minus 2, times our quotient, and again, constant, linear, quadratic, cubic, quartic, so x to the 4th, plus 2x cubed, plus 4x squared, plus 8x, plus 16, and then there's no remainder. So that is our solution. Now in D, 1 will go in the box. Remember, constant of the divisor, but change the sign. And then the coefficients of the dividend go right out here. And that will be our remainder in that space. So, first thing we do is carry down the 4. 1 times 4 is 4. Negative 3 plus 4 is 1. 1 times 1 is 1. 2 plus 1, 3. 1 times 3 is 3. Negative 3 plus 3 is 0. So once again, we have no remainder. And in our quotient, this is constant, linear, quadratic. So, in quotient remainder theorem form, our dividend is equal to the divisor times the quotient, which is a quadratic. And again, there is no remainder. And we do have 2 more. So for E, in the box, we'll go negative 2. Remember, change the sign. And then we have our coefficients straight out from that box. And down here will be our remainder. So, first step, bring down the 1. Negative 2 times 1 is negative 2. When adding these, we get negative 16. Negative 2 times negative 16 is 32. Adding those two, we get 83. Negative 2 times 83 is negative 166, and when we add those, we get negative 220. So in quotient remainder theorem form, we start with the divisor, which is x cubed minus 14 x squared plus, that's a squared, plus 51x minus 54 equals our divisor times our quotient, which is a constant linear quadratic, plus our remainder. I think you'll agree that synthetic division is the way to go, but again, you can only use synthetic division when our divisor is linear and the leading coefficient there is 1. So finally, F7 will go in the box. And here are the coefficients on those terms. You'll notice once again, since I don't have a quadratic term in the divisor, I fill that space with a 0. So now we're ready to carry out the synthetic division by carrying down the 1. 7 times 1 is 7. Adding those two, we get 7. 7 times 7 is 49. Negative 57 and 49 is negative 8. 7 times negative 8 is negative 56. And looky here, again, we have no remainder. So writing it in quotient remainder theorem form, we start with the dividend. X cubed minus 57x plus 56 is equal to our divisor, x minus 7, times our quotient. Our quotient is constant linear quadratic, x squared plus 7x minus 8, and we have no remainder. So there is the synthetic division for polynomials.